All right, I don't have the announcement slide available because of that file corruption issue, but I'll just let you know the homework assignment that you've got on your plate right now, homework 9, that's going to be due on Friday at 12 o'clock. It's something that you'll be able to finish after today's class, but I wanted to give you some additional time, so we're going to follow the same pattern as we have for the last couple of weeks. The other thing to remind you about is that we also have the project hanging over your heads, and that's going to be due early November, so I don't remember the exact date. I'm sure you've got it there on the printout of the course schedule. Oh, actually, I do have it here. Let's see. So the project due, oh no, that's not it. Wrong schedule. Do you have a question, Jeffrey?
How many questions roughly on the homework?
There are 5 questions. Any other questions? All right, so today we're talking about incremental analysis again. Remember when we were doing incremental analysis before, it was to find the rate of return between two alternatives. I keep repeating the same phrase, decision criteria. But what was the decision criteria for incremental rate of return analysis? When you're comparing two options, one of them's more expensive than the other, how would you know whether to choose the more expensive option? Yeah?
If the IRR of the difference of the two is higher than the MAR, you'd accept the more expensive option.
Perfect. I couldn't have said it better myself. That's absolutely right. So he said if the internal rate of return of the increment is higher than the MAR, then you choose the more expensive alternative. I should have a quiz one of these days where I just ask you various decision criteria. Like, what's the decision criteria for present worth analysis? What's the decision criteria for internal rate of return analysis? And so on and so forth. So that's how we applied it for projects that are seeking profit. Now, as we talked about last week on Thursday, public works type projects don't always generate a profit. There's lots of things that are worth doing that cost more than they actually provide in revenue. And it's when we try and consider other value besides just cash revenue that we can find justification for doing those types of projects. And so when there's an improvement to public safety, when there's an improvement in health, reducing risk, reducing noise, reducing pollution, all of those things are worth doing, but they don't actually generate cash revenue. And so on Thursday, we looked at benefit cost analysis, and we found an approach that said if the B to C ratio is greater than 1, then a project is acceptable. And the reason why a project is acceptable when the B to C ratio is greater than 1 is it means you're getting more than $1 of benefit for every $1 of cost. So now today in incremental analysis, we're going to apply two ideas together. We're going to apply incremental analysis for comparing two things, and we're going to apply benefit cost analysis for evaluating public sector projects. Now, the reason why we did, one of the reasons why we did incremental analysis with IRR is that you can't use IRR alone to pick which project is best. Do you remember that? That IRR can only be used for initial screening. The project that has the highest IRR isn't necessarily the best project. So that's something you've already heard before and learned about. Today there's something similar that's true about public sector projects. And that is the project with the highest B to C ratio isn't necessarily the best project. You can use B to C ratio for initial screening to tell you if a project is thumbs up or thumbs down, but to know which project is best, you have to do an incremental analysis. All right, so incremental analysis can be used to compare alternatives if we use the B to C ratio, and this is just showing the conventional. Remember that there's also the modified, and that formula is in the previous lecture notes. Here are some pictures that are depicting different flood control measures. And this is an illustration of a type of project that has to be analyzed according to benefit-cost ratio, because things like flood walls and pumps that are removing floodwaters from behind a flood wall, those types of measures don't generate revenue. Like taking a house and lifting it up so that it doesn't get flooded when the waters rise, that doesn't generate cash. But it can avoid disbenefits, and it can avoid, it can provide benefits like reduced frequency of displacement when there's a flood. So these may be good things to do, and there are three options here, and the question is, if we're going to have mutually exclusive alternatives, which one should we select? And so when you're doing incremental analysis, you follow the same approach that you did with incremental rate of return analysis, where you start with the cheapest option, and then you do a one versus the other comparison of the cheapest and the next most expensive. So you calculate the increment between those two. The incremental initial cost, the incremental maintenance and operation cost, the incremental benefit, the incremental disbenefit. And remember that these different costs, benefit and disbenefit, in a problem statement, they'll usually be described in terms of some of them are annual and some of them are at year zero. Initial construction cost is usually at year zero. So before you combine these dollars together, you have to put them all to the same time. So you have to take everything to the future, to a present worth or annual worth. And remember that a big part of the uncertainty of this whole process is that we have to come up with a dollar estimate of what the benefits are and a dollar estimate of the disbenefits. It's the best we can do in a lot of cases. So here's what that conventional benefit cost formula looks like when we apply the incremental analysis to it. When we're comparing two alternatives, we put in the difference in benefits between them minus the difference in the disbenefits between them, divided by the difference in costs, both in initial terms and the maintenance and operation terms. So you can put it into the conventional or modified, and either way, when the increment is greater than 1, then that means the more expensive alternative is justified, because what that means is that the extra money you spend to do one option that's more expensive compared to the cheaper one, it means that extra money is giving you more than $1 of benefit for each additional dollar in cost. So the new defender, meaning the best option, is the more expensive alternative if the ratio is greater than 1. But if the incremental ratio is less than 1, that means that you reject the more expensive alternative, and then the cheaper alternative remains the best option. And then you do the comparison for the next most expensive. So in the same way that you've ordered from cheapest to more expensive, you do the same thing here. All right, so we have an in-class exercise today that you're going to do with Excel. On the front side of the paper, I have the problem statement, some additional information. And what I'd like you to try and do, spend just a few minutes thinking about before you start putting it into the computer. Think about how would you set up, like how would you format your spreadsheet. Now, if you strike out and you just can't figure out how to do the template on your own, I've provided some guidance on the back. But I think it's a good habit for you to start to get into thinking about, you know how Excel can be used. You've seen plenty of problems like this set up through the semester. I think it's a good practice for you to figure out how to use Excel without the template being provided to solve a problem. So spend maybe 5 minutes after you read the problem statement, spend a little bit of time thinking about how you want to structure it as a spreadsheet, and then if you still don't know exactly what to do, then take a look at the template that's on the back side of the page. I've intentionally made this a little bit tricky. We have option A, B, C, D. They're not in order in terms of cost. So you're going to have to reorder them when you do the analysis. Remember, you start with cheapest and then you work your way up towards the more expensive alternatives. You have two options for the benefits part of it. You can either create a column that's like the sum of the benefits, where you add up the three different components, or you can just put that sum into the function where you're taking it to the present. So you'll notice that what I've done is here in my formula for taking the PV of the benefits, I say the PV at 6% for 75 years, and then what is in that payment field is the sum of the flood, fire, and recreation benefits. So I just put a parenthesis and I'm adding it together inside of the field where it's looking for the total recurring amount. Once you finish the initial screening, it looks like they're all acceptable. So then the incremental analysis is going to have these as the column titles. We're just going to have the delta CI between two options, the delta C for maintenance and operations, the delta benefits. Now you don't have to search through the symbols and find that delta. You can just type in DELTA. But the point is that you are comparing the cheapest option and the next most expensive option. So you're subtracting B, you're doing B minus A for each of these columns. And you can see that the incremental benefit cost is 2.57. So that means B is better than A. It means that for each dollar of additional costs, you're getting $2.57 of benefits when you spend the extra money to do option B instead of option A. So B is the next champion, and then you'll do B versus C to find out what happens there. Let me zoom the screen in on the incremental analysis part so that's a little bit easier to see. Okay, let's walk through the decision analysis in this incremental comparison. So the first matchup was B versus A, and in the incremental analysis, the delta benefit cost was 2.57. So that means do B instead of A. In the next comparison, C versus B, so I'm subtracting B from C because C is more expensive. The incremental benefit cost is less than 1. So that means that we reject C. So the final comparison isn't D versus C, because C's been thrown out. The final comparison is D versus B. And you'll see that the incremental benefit cost is greater than 1, so that means option D is the best. Now the last question asks, how high could the interest rate go and you still have an acceptable project? So whether a project is acceptable or not acceptable is based on this initial conventional benefit cost. And so here what I did was I created a copy of my spreadsheet. If you just right click on the bottom tab and have it say move or copy, and then you create a copy, then you can have your original work and not have to change it, but then the second tab that allows us to play around with the interest rate. So I'm looking for what interest rate can I keep increasing to and still have at least one of these be greater than 1. So an acceptable option. And so what I do for that iteration is I just, first of all, let's manually play with some of this. So 8%, what about 10%? What about 13%? All right, so at 13%, only one of them is still acceptable. So the question is, how high can the interest rate go and have still this one be acceptable? So I could do a goal seek, data, what if analysis, goal seek, and I want this to be equal to 1 by changing the interest rate, and go. And what it shows me is I can take the interest rate as high as 14.5%. And once it's at 14.5%, only option B is acceptable. So the main thing you learned today was the incremental analysis. This is the most important thing. And then this question 2 was just kind of refreshing the goal seek idea and the making you aware of the effective interest rates. As interest rates go up, the value of things in the future goes down. And so it's going to make us so that the benefit cost is less and less acceptable. Okay, unfortunately we're out of time for today. By the way, just since I mentioned it earlier, the due date for the project is Tuesday, November 12th. So your homework assignment for this week is due this Friday at noon. And besides the homework assignment, the other thing you should be thinking about, the other thing on your plate, is the project. All right, I'll see you in class on Thursday.